We are on a project, Ada, Oklahoma. Got 14 panels on this array, 14 panels on that array. 20 panels on that taller face up there. Kind of a nice view. Let's go check out downstairs. Here we are at ground level. This is a west-facing array, and this is a south-facing array. Here's the customer utility meter. We're gonna have an AC disconnect, solar AC disconnect, and a DG meter outside. We're probably gonna set it right in here, actually. Just what makes sense for the way we're gonna do the inside. I'll show you that now. So, already got it all marked out. And here, we've got two 200 amp Cutler hammer panels. We're gonna have a transfer switch there, two Sol-Ark 15Ks, and a 10x10 gutter, and then 3 of the EG4 indoor wall mount batteries. So, pretty beefy system. They're gonna have the ability to add a standby generator in the future if they like, add more storage, and they've got a lot more headroom on adding some more PV in the future as well. So, it'll be a great system. It's gonna have 48 Mission 410 watt panels, modules feeding this system. So we'll have plenty of headroom on these inverters for future addition. We are getting these Sol-Arks set up with these batteries. Very talented David.
See?
We got 3 of these EG4 14.3 kilowatt hour indoor units. We used our own gutter, but we cut the openings out and then used that rubber edging, which worked out really, really nicely.
Again.
Show you what the arrays look like. Turned out really nice. Nice view. We've got 14 Mission 410s, another 14 Mission 410s. And 20 Mission 410s. There's no attic on that one, so we had to see the conduit right there. And a rooftop junction box down on this lower level up here. So it turned out really nice. So we're about to start testing, commissioning, setting up the site. Here's a little bit of our electrical work here. A lot of LBs, a lot of conduit bodies. So the meter feeds directly to those automatic transfer switches. We have our DG meter for the utility. And we have our disconnect. Good. Oh, not going in there. Kind of explain the wiring a little bit. So you've got 2 automatic transfer switches. You don't see a lot of guys using these with Sol-Ark systems, but the reason we like to is they serve a few purposes. The first one is that that's obviously a bypass, so you can automatically or manually decide whether or not you want the load to feed through the Sol-Arks or to feed through the transfer switches. The other one is, because we have to use DG meters here, production meters, with this utility, this allows us in normal operations to run all of the load straight through the transfer switches rather than through here. And it allows our export to come out the grid through the grid PDB and out through the disconnect the production meter. So all we're reading is production for the most part. So that's kind of our reasoning for it. We really like using them. They're really great. What we do is we put a normally closed relay in our master transfer switch with a 240 volt coil and a 30 to 300 second delay on return. And that then use the 12 volt out of the master Sol-Ark feeding through the relay into the transfer coils of both the units. So turning out good. We'll get it turned on. All right, just about done. We tested for transfer. Everything's great. We're exporting out to the grid right now. Batteries are looking great. They paralleled perfectly. They're communicating in closed loop communication with the Sol-Arks. And that's about all she wrote. If you need a system like this or need any help designing your own, feel free to give us a call. Thanks.